What's up, broskies? Welcome back to episode 2 of the platformer tutorial. Today, we'll be implementing a movement script on the player model. The script, along with the player model assets, will be linked down below. Warning, I will be going into more detail in this episode, so it will be lengthy. Try to stay with me. If you have any problems, concerns, or questions, ask them down below. I'm very active. Onto the tutorial. I've been using this movement script for almost all my 2D game productions, but in all honesty, I didn't make it myself. The script I'm about to relay to you guys is built off of Blackthorn Prod's triple jump platformer control script. All props go to him. Without his videos, I would probably have a more difficult time learning to code and learn the aspects of Unity. Link to his original video down below. First off, I will add a sprite to the hierarchy, and why I use a sprite over a UI image is because recently I found that sprites don't constrict your CPU as much as a moving UI image would. The difference between the two is the render. UI image uses a canvas while sprites use sprite render. UI has more load in terms of functionality to the layout of rendering UI. I'll link a forum thread so you could read more about it. In the project window, make a scripts folder to stay more organized and add a C# script. Let's call it movement. My coding environment is Visual Studio Code. If you want to use the same environment as mine, you can do so at the Edit, then Preferences, and External Tools. Change the external script editor to either VS Code or other preference you desire. To start off, make sure you're using the 3 libraries listed here and using the mono behavior class. If for some reason at the beginning of the tutorial you messed up the name of the script and you renamed it back to movement, make sure you also change it here. First, you want to declare some floats. A float is any number with a decimal, meaning 1.0 is a float, while 1 is an integer. Okay, so public means this value can be changed by any other script or in the inspector, while private means it can only be changed within the script itself. Think of it as permissions or files that can only be ran as admin. By making these 2 floats public, we are able to change their value in the inspector. Let Unity save. Alright, so if we add the script to the player... Okay, so my bad, this is supposed to be private. Resaving that. So this should not be seen in the inspector anymore, like before. So it was like this. Now once it's private, it's no longer a public. You can no longer see it. I'll explain why I made move input private soon. Next, I'll need to reference a rigid body. First, in Unity, add a rigid body 2D component to the player. This component basically is Unity's 2D physics system, and be thankful for it, as physics systems are an asshole to make. We need to control the velocity of the player using this component, and doing so is as easy as adding it to the script. One beginner way to reference a component in code is to make a private rigid body 2D and assign it a variable. Reference it in the start function by calling the variable and assigning it the component of which the script is on. Reference it in the start function by calling the variable and assigning it the component of which the script is on. Now that may sound confusing, but let me explain. RB is getting the component that we just added, and the way it looks for that component is by checking the game object that it is currently on and checks if it currently has a rigid body 2D active. You can see what I just said by right here. So inside the player game object, the script basically looks for everything in the inspector and checks if the game object itself has a rigid body 2D, which in our case it does. Alright, let me speed this up a little. So the next function is a fixed update. This is different than a normal update function like seen up here, because a fixed update function can run once, 0, or several times per frame, which an update function runs one time per frame. This is desirable, especially for movement, which we will reference the move input to be the input get axis of your horizontal key. We're basically setting the float to be your horizontal axis in your input manager. By default, these keys are set as left and right arrow keys. You can also make it as get axis raw for more sharp movement. To add speed to the rigid body, we reference rb.velocity to equal a new vector 2 and change the x value to be the movement input times the speed value, which is self-explanatory. You're getting left or right and timesing it by the speed of your public float. Okay, so at this point in time we are missing two key components along with a bonus feature. The first one is the player is falling through. This is as easy as adding colliders onto the tile map and the player itself. Remember to lock the player's z-axis to prevent unwanted rotation. To jump, we'll work on the isGrounded variable, which we will reference 4 lines of code. These will work together to get what is and what is not ground. In the fixed update, we will call isGrounded to be going back into Unity. Add a game object as a child of your player, making it follow wherever the player goes. I'm gonna call it ground check, and this will act as your ground check. You can add whatever 2D collider you want to use. Some may even use raycasting as a form of a check value, but I'll be using a circle collider and set it as a trigger. Make sure it's at the bottom of the player's feet to check whether or not he's grounded or not. And also make sure it's below your first box collider. My explanation would be if it's inside the box collider and it touches the ground, the box collider will be in the way of the actual circle collider, and the circle collider will not be able to check whether or not something is grounded or not. So now in the code, an invisible circle will overlap the new game object we just added and use 3 values. It will use the ground check position, the check radius, meaning how far the radius of the trigger will go, and what layer counts as ground. In the update function, we will add these lines of code. So if your arrow key is pressed, the rigid body velocity is going up by your jump force value. Back to Unity, I'm gonna change the value to something random and try and jump. I'll set it as 5. You see how the player is infinitely jumping. The feature we just added in the code with the what is ground will basically fix this bug. So if the player jumps, it will check if after it jumps, if it's in the air or if it's in the ground. If it is touching the ground, it will allow the player to jump, but if it's not, it will just go down. We'll add that in the code right now. I'm going to copy and paste 2 values which will be used for our number of jumps. Next, I'll replace this if statement and paste. So this may look like a lot, but it is really simple. The isGrounded variable will equal true when the circle collider 2D hits the what is ground layer. And if we go back to Unity and set the, where is it? And set the what is ground. Okay. To check what is ground, we will go to the tile map, make a new layer, and call it ground. Now if we assign that layer to the ground, and inside the movement script, we will change the what is ground to ground. So now whenever the tiny circle collider down here goes through the tile map, it will check if the tile map is actually grounded or not. On our next line down, we will check if any input of the arrow key is pressed and if the extra jumps is larger than 0. And if it is, the velocity of the rigid body will be pushed up by the jump force, and the extra jumps value will be subtracted by 1. This next else if statement means if the arrow key is pressed up and the extra jumps is equal to value and the isGrounded variable is true, it will be added up, but this time extra jumps will not be subtracted by 1. And these next few lines are practically the same thing, but with the space key. Okay, while reviewing my video, I forgot to mention one thing. So, if the player just landed on the ground, it will reset their extra jumps by the extra jumps value. So basically, this extra jumps value is static, meaning it doesn't change, while extra jumps will be changed. So while it's getting subtracted by 1, and it runs out of extra jumps, it will no longer be able to jump. But once it hits the ground, extra jumps will reset back to its original value. Don't forget to drag and drop the ground check game object into the ground check transform. We will change the check radius to, let's say, 1 and the extra jump to 2, while keeping the extra jumps value to 2. Alright, see, so 1, 2, 3. 1, 2, 3. It's not jumping anymore. 1, 2, 3. Okay, so the code works well. I think the speed is a little too high, no? Let's change that down to like the float, right? Yeah, it's a float. So let's change it to like, I want to say 6.5. 1, 2, 3. I don't know, that's a little too slow. Let's add one more. 7.5. Okay, I like that speed. Alright, it looks fine. So, well, one last thing I'm going to add for this video is the flip. So whenever we turn left, the sprite will flip left. Let's go back into the code and add that real quick. So since our player is originally facing right, we're going to want to make a private bool variable that makes it so facing right equals true. And then down to the fixed update function, we're going to add below that is grounded. I don't think it matters if it's below or above, you can put it anywhere you want. It checks if facing right equals false, and if it is facing false and the move input is more than 0, meaning if you click the right arrow, that means your move input will be equal to 1, but if you click left, your move input will be equal to -1. So if facing right is false and you click on you're going right, it will call the flip function, which we will add soon. And if it's facing right and the move input is going left, it will flip again. And we will add the flip right here. Make sure you call the void function, void flip. So if facing right is not equal to facing right, the transform of the player will rotate 180 degrees on the y-axis. Now if we save, I hope it's going to work. Okay, right, left. Okay, cool, it works. Okay, so that concludes our video. If you have any questions, comments, or concerns, please mention them down below. I'll put this entire script along with the Unity files in a GitHub so you guys can, if I'm going too fast, you guys can follow along using that. Nonetheless, I hope you guys have a wonderful day. Have a good one.